In the previous class, we were discussing about the mean terms and max terms. So we will start with that only. So in mean terms and max terms, we have started. So basically, we know a function is there, a Boolean function. This Boolean function can be represented in terms of a function of, you can say, inputs. So different inputs are there. Suppose 3 inputs are there. So a Boolean function can be represented in terms of different inputs. Okay. So these different inputs can be represented in terms of different combinations, like x can be in x and x bar complement form, y complement form, z complement form. So combination of these Boolean variables either in a non-complemented or complementary form with an operator, either and or operator, will be forming a mean or max terms. So we will see how it forms. So before that, we will just see, suppose a single variable is there x. So it can be represented either in without a complement or with a complement, means it will be x bar. So if it is x, means a single variable is there. So it can take a value, suppose it can take a value of 1, or it can take a value of 0. So two possibilities are there to represent x, either x or x bar. Similarly, if there are two variables x and y, suppose, so it can have 4 different possible combinations. Okay, so yeah, x bar y bar, x bar y, x y bar, x and y. So it is 0 0 0 1 1 0 1 1. So with two variables, we have these combinations of x and y. So these combinations have been included with AND operation. So these combinations with an AND operator, we have this possibilities. So with respect to two variables, we have 2 to the power 2 possible combinations of variables, and each of these terms is called a mean term. Okay, so each of these terms will be called mean terms. We can easily find out with the help of an example. We will see the next. So this is how we take. So with one variable, it has the possible combination is 2 to the power 1 will be there. With two variables, it is having 2 to the power 2. So 2 to the power 2 possible number of mean terms will be there for n is equals to 2. Similarly, if n variables are there, if n variables means n input variables are there, with respect to that, possible mean terms will be 2 to the power n. So if two variables are there, 2 to the power 2 mean terms will be possible. Similarly, if n variables are there, 2 to the power n will be the possible mean terms for n variable or n input variables are there for a function. So similar is the case if we have used AND operator. Similarly, if we are going to use OR operator for two variables x and y with an OR operator, the possible combinations will be like x. If it is OR, instead of ANDing, we will be ORing. So x, y, x bar, y bar. So again, here 2 to the power 2 combinations are there. So these sum terms or R terms of variables are called max terms. So minterms and maxterms. So minterms will be obtained with the help of AND operator to the input variables. And okay, so this might be looking confusing, so we will proceed with an example. So that we have already gone in the previous class, so we will again start with here only. So we have a truth table for two different functions f1 and f2. So with respect to that, we need to find out, suppose, mean terms and max terms. So whenever a function is there, a function is having 1 or 0 with respect to some input variables, it is having either 0 or 1. So whenever it is having 1, we will take that combination of inputs that will give us the mean terms. So mean terms will be these. So first mean terms will be like where the function is 1. Where is the function is 1, that will be a 1 mean term, that is x0, y0 and z1. So it will be x bar, y bar, z. Similarly for others, x, y bar, z bar plus x, y bar, z plus x, y, z bar plus x, y, z. So this will be a mean term, and this will be result into a function, that is f1. So f1 will be represented by these mean terms. Similarly, f1 can also be represented by the max terms also. f1, if we talk about the zeros, so here wherever the 0 is there, that will be giving out the mean terms, the max terms. So f1 can be represented either in mean terms or max terms. So if we talk about the f1 in terms of max terms, it will be where it is 0. So if it is 0, we will be representing it by x plus y plus z. If it is 0, then we will be not considering any bar. Okay, we will be proceeding the product terms. So sum of product. So mean terms are written into product of sum form, and max terms are written into uh, product of sum forms. Okay, so it is max terms. So f1 can be written in the terms of max terms. So it will be first term, then x plus y plus a z1 is there, so we will be writing z bar. So it is 0, 1. So here 1 is y is 1, so it will be this. The next term will be x, y plus z. So here y and z are 1, 1. So we will make y bar and z bar because it is 1, 1. So it is just complement to main terms writing. Okay. So always the max term is written in terms of sum of product, the sum of variables, then producting it. Okay, and mean terms will be written the product of sum. So mean term will be product of sum. So the variables will be product first and then it will be added. So from the truth table, we can directly write a function in terms of either mean terms or max term. So the mean terms can further be written like, so these are the mean terms or max terms. So mean terms, the property of the mean term and max term is these mean term and max term will always be containing all the possible variables. So here f1 is function of 3 input variables, and this f1 is function of 3 input variable. And if f1 is represented, if f1 is represented by mean terms or max terms, then f1 is said to be in canonical form. So canonical form is if any function is there, if it is written in terms of its mean terms or in terms of max terms, then it will be called as it is written in canonical form. So canonical form will be containing all the mean terms or all the max terms. And in mean terms and max terms, so mean term or a max term will contain all the variables, all the variables in each term. That means if this is one term, this is one term, this is one mean term, this is another mean term. Okay, so next there's 1 2 3 4 and 5. So there are 5 mean terms, and each mean term will be constituting the each input variable. Okay, then in terms of max terms, each max term will also be constituting each variable. So this is the property of mean terms or max terms. So mean term and max terms will always be constituting the all the possible input variables. And if any function is written in terms of mean terms or max terms, that will be called as it is written in canonical form. So canonical form will be constituting the all the input variables. Okay, so any function is there. So any function can be written in two different forms. So one is called canonical form, another one is called standard form. So we will see later like what is standard form. So first we will see what is canonical form. So canonical form is the function that will be constituting either mean terms or max terms, and in mean terms itself says it will be having all the input variables that are or Boolean variable that is defining the function. Okay, so standard in here only we will see in standard form. So in canonical form, function will be function have either mean terms or max terms. But in standard form, either mean term or max term means it will be having all the variables, all the Boolean function. Canonical form means or we can say function will be represented in terms of all input variables. But in case of standard form, a function can be represented with the help of either 1 or 2 or either 1 or 2 or any number of variables. Okay, so in standard form, a function will be having either 1, 2 or any number of variables that is possible. But in canonical form, each term, mean term or max term, will be having all input variables. Okay, this is how we will be representing. So there are some advantages and disadvantages of canonical and standard form. So we will see from there only you can just identify if we are going to use each term. So to represent a function in terms of circuit, we will be requiring large number of gates. But if we have written a function in standard form, that means it is in reduced form or it is utilizing less number of variables, then it will be easy for us to implement a circuit with less number of gates. So this will basically reduce our circuit complexity. Okay, so this is the advantage of standard form, and in canonical form basically it will be requiring large number of gates and it is quite complex in terms of representation. Okay, so just from there we can just see if a truth table is given, if in the truth table a function is defined, so this function is defined will be having some values that will be either 0 or 1. So it is a 0 or 1 based on the input combination. So whenever there is 1 is there, so this is 1, this is 1, this is 1 and this is 1. So these ones will be defining the mean terms. And similarly, if the function is having, wherever it is having zeros, these zeros will be defining the max term of the function. Okay, and also a mean term is there, so this mean term is written in sum of product form, and max term is written in product of sum form. Okay, we have seen from the previous. So this is how, if we are having three possible binary variables are there, so three variables are there, so for three variables how the mean terms and max terms will be defined. So if three variable is there, so 0 0 0, so its mean term will be x bar, y bar, z bar, and it is represented by m0. Okay, and the similar combination of inputs we have the max terms. So max terms will be represented by x plus y plus z, and it is represented as capital M, and the mean terms will be represented in small m. Okay, so if it is 0, it represents a decimal, so it is decimal. So decimal 0 1 2 3 4 5 6 and 7. So 0 0 0 when we will be representing small m 0, so small m 0 represents this term or this combination of input. So this is a mean term that is representing a 0 value of input combinations. Similarly, a 0 value of input combination in max terms will be represented by x plus y plus z. It will be represented by capital M0. Similarly, if small m5 is written, that means it will be representing input combination of 101, that is 5 of input combinations. And with respect to that, the function will be x, y bar, z. Similar to that, if you want to have representation in terms of max terms, it will be representing m5. Also in terms of representation, if we talk about, so these functions, so f1 and f2 is there, so these functions can be represented in terms of direct form, this min terms and max terms. So instead of writing the function, the input combinations, we directly write here f1. We can represent like f1 is represented by the 001. So 001 represents in terms of mean terms, it will be m1, this is m0, this is m2, m3, m4, m5, m6, m7. So this can be directly concluded from this table. So we have seen, so with the help of this table we can directly write like any function is given, so with respect to that function we can directly write the function in terms of mean terms. If we want to write in mean terms, it will be the summation of the mean terms. So it is because it is the product of sum of product. Mean terms is written in terms of product of sum of product. Okay, so it is sum of product terms. So it is sum of product terms, so it is sum, that's why the summation is used. So summation we will be writing, and different mean terms are there. So m1 is there, so wherever this function f1 is 1, we will be writing with respect to that the mean terms. So m1 is there, so if it is written by m1 comma, this is m4 comma m5 comma m6 comma m7. So this is how we can write f1 in terms of mean term. Similarly, if we want to write in terms of max terms also, we can write f1 in terms of max terms. So max terms is written like the product term. So it is sum of product of sum. So it is product of some terms. So it is product of some terms. So per product we write it this product function. So it is represented like pi structure. Okay. So it is product. It indicates the product. Okay. So whatever the terms is there, we will be making the product of each term. Okay. So with respect to that, this is uh, 0 0 0. So this is where the 0 term is there. The function f1 is 0. So this will be representing the product term. The and we need to write in terms of max term. So max term will be represented by capital M. Capital M terms will be there. Okay. So this is how the capital M terms 0, 1, 2, 3 and so on. It will be there. So if it is there, so it is f1 is capital M0, capital M2, capital M3. So it is represented by the capital terms 0, 2 and 3. So the same function can be written in terms of min terms or in terms of max terms, like that. Now we will see how we can convert between canonical forms. So canonical forms will be either in min terms or max terms. Okay. So canonical form represents min term or max term. So if we want to convert a function from min terms to max term or max term to min terms, we can do that directly. Okay. So we can just see, we can just take the example from the above function we have defined also, or we can directly write from here also. So if we want to have a conversion, so first for function 1, f1 is written in terms of min terms. So in terms of min terms, we will be finding where it is 1 is there. So it is 1 at this 0 0 1 is there. So 0 0 1 means it will be the summation of m1, then m4, then m7. Okay. So these are the mean terms, and if we want to convert it into the max term, the steps that we generally follow is, what we need to do is we need to complement each side. We will be complementing each side. So it is f1 complement, then summation m1, m4, m7, and we need to complement this also. So if we want to complement it, or we can represent it like, if it is mean terms, we can represent it like directly x bar, y bar, z, plus if it is 4, x, y bar, z bar, plus if it is 7, x, y and z. This is how we can represent. Okay. So f1 complement is equals to the complement of this, and if we want to complement this term, we can directly write here is f1 complement is equals to f1 complement is equals to, now we need to complement each other. So to complement, what we need to do is we need to change the variable. So each variable will be complemented, and plus will be become dot, and dot becomes plus. So we can write here is like, it will become x plus y plus z, it will become bar, and this plus become dot, these dots become plus, and each variable will be complemented. So it will be complemented, it becomes this, then it has become like x plus y plus z, and each term will be complemented. Okay. So f1 bar will be equals to this function. Okay. Now again we want to complement each side. So again, if we want to complement on each side, we will be complementing it. So it will become, if we are complementing it, so it is f1 complement means it will be directly written as f1, it will be removed, and in that side it will become again the complement of each term. So this each term, so here f1 can be represented in terms of, so this each term represent the capital M1, this represent capital M4, and this represents capital M7. So from there we can adjust say is, so if any function is there, it is represented in terms of the complement of, so initially it should be in terms of m1 m4 and m7, that is in mean terms, but it is representing the complement of these terms, or we can expand it further, then we can see like it is m1 bar, we can write like, so it can be written like capital M1 capital M4 capital M7 whole complement. Okay, so if we complement is expanded by using De Morgan's theorem, it will be M1 bar plus M4 bar plus M7 bar. So if we can see this as the case, or we can write in summation form is like it is capital M1 comma bar capital M4 bar capital M7 bar. So this was the function f1, and previously we have represented like f1 is the summation of m1 m4 and m7. So with respect to the previous expression, it can be represented like summation of a small m1, that means mean terms, m4 and m7. So by comparing this, we can, from there we can just see like m1 mean terms m1 is equals to complement of max term, m4 is equals to complement of max term 4, and m small m, that is mean term 7 m7 is complement of max term 7. So from there we can just conclude like the mean terms will be equals to complement of the max term. So if this is true, then with the help of that we can just write like we can write f1 in terms of either mean terms or max term. So if it is mean term or max term, that will be written that will be with respect to the complement representation of mi, that is small mi is equals to capital Mi complement. So here the mean terms can be represented in the complement form of max terms. Okay, and that means if any function is there that is having this representation, so from there we can just we can just see f1 was there, that is summation of m1 m4 m7. So now if we want to write f1 in terms of max term, this was the representation, but if we want to represent its complement, that is if f1 is represented in terms of, this is sum of product term, this is in sum of product, if we want to write in terms of product of sum, then whatever the remaining terms are there, we will be writing that. So f1 will be written like capital M0 capital M2 capital M3 capital M5 capital M6. So this will be your product of sum form. So this is sum of product form and this is product of sum form. Now we will take some examples. So here suppose find the product of max terms expression for this function. So we need to find out the product of max terms. Okay, so instead of it is written in terms of min terms. So if we want to find out in terms of a max term, so the result will be just we will be getting like whatever its complement is there. So this is a function. If we write its complement on both sides, so whatever the complement is there, like whenever there is a 0, it is min term. So the function f is 1 in case of m1 and m2, m3 and m5 and m7. And if we complement it, that means if we want to write in terms of product terms, so it will be the complement. So f dash or f complement will be the summation of product of max terms. Okay, so the function can also be represented in terms of max terms. That will be here the product of max terms, which is 0, 4 and 6. Okay, so 0, 4 and 6 will be the product of max terms. So product of max terms, if we write or expand it further, we can get like the function f will be written in terms of the product of max terms. Okay, so next is we need to write the function in terms of sum of min terms. So this is the function in terms of max terms. So min terms will be just the remaining combination of inputs that is available. So here 1, 3, 4, 6 is the max terms, then the min terms will be the remaining part. So remaining part will be like it will be the 0, 2, 5 and 7. So 0, 2, 5 and 7 summation of 0, 2, 5, 7 will be giving out the sum of min terms. So if we will expand it, so it will be written like this. So 0 will be x bar, y bar, z bar, and similarly for 2 and for 3, for 5 and 7. We can just write it is 0, 0, 0. From here, if we write it is 0, 1, 0, 1, 0, 1, 1, 1, 1. So this is 0, 2, 5 and 7. So this is representing this. So the function this can be written in terms of product of sum form or in terms of max terms. So this is max terms. If we want to write in min terms, so this is the min terms will be the remaining terms of this function, or the complement. If we do the complement of it, okay, so the remaining terms that is left, that will be coming out to be here. Okay, so another question is there. So here identify the max min terms and max terms of the truth table for the function f. Okay, so this is the function. We need to identify the min terms and max terms. So from there we can identify the min terms and max terms. Okay, so just we can see here. So whenever if we want to find out the min terms, so for min terms we will be considering the ones where the function is 1, that will be representing the min terms. So here it is m0, m1 is there, m3, m4 and m6. So summation of min terms will be m1, 3, 4 and 6. That will be min terms, and the remaining, that is 0, 0, 0, 0. So wherever there is a 0, that will be giving out the max terms. So it is 0, capital M0, this is capital M2, capital M5, and this is capital M7. So 0, 2, 5, 7. 0, 2, 5, 7 will be giving out the max terms. It is written f bar, it should be f only. So the function f can be represented either in terms of max term or min terms. So it is in min terms. So in max term, the remaining terms will be representing the max terms, like here. Okay, so the remaining terms where it is 0, that will be representing the max terms. So that will be 0, 4 and 6 in this. So this is how the minterm and maxterm is represented. The next form is standard form. So we have seen the standard form. So standard form is the form where a function will be represented in either 1 or 2 or any number of variables. Okay, so it is not mandatory like in standard form the function should be written in terms of minterm or maxterms. So here we can write in terms of either any of the number of input variables. So suppose consider an example. So if this is the example like f1 is written by, so here f1 is written like y bar plus xy plus x bar y z bar. So from this function we can expression we can just see like the function f1 is a function of input variables. So input variables are here, x are there, y are there, and z is also there. So there are three different input variables are there. So different input variables are there, three input variables are there, but each term is having like the first term is having only one variable, this is having two variable, and this is having three variables. So this function is written in terms of input variables, but these input variables are not in the form of canonical form, or if it is canonical form means if any function is there in canonical form, so each term, so this term should be containing all the input variables, but here it is only one variable is there, here two variables are there, here three variables are there. That's why it is called standard form. Okay, so most frequently the standard form is always used, but the disadvantage here we can consider like from the standard form of the function we cannot directly write like which term of the different combinations. So we can just see, we have seen here what is the different possible combinations of three input variables, and with respect to that what is the different combinations of inputs. So 0 0 0 1 2 and 3 up to 7 different combinations are there, and different mean terms are there. Similarly different max terms are there. So from the function itself we have decided, so from the function itself we can decide like what are the different combination of inputs are there, which mean terms or which input combination is there into this function. But from seeing the standard form we cannot decide like which mean term is available into this function. Each term we cannot say it is a mean term. So mean term means it should be constituting all the input variables, or max term is constituting all the input variables, but it is each term is represented such that it cannot depict like what mean terms are available into this function f1, but previous functions are able to directly indicate like what mean terms are available into this function. Okay, so this is like a reduced form. So this reduced form is having the advantage like it can use less number of, or it requires less number of logic gates to implement a function f1. So similar we can just see like how we can represent the f1. So f1 can be represented here directly in the form like first we need to AND all the functions, all the variables. So ANDing is done on the first stage, and then on the second stage we are adding or ORing. Okay, so first it is ANDing and then ORing. So why? Because it is written in terms of sum of product terms. So that's why it is called sum of product terms, sum of product form. Okay, the second function we can consider. So here another function f2 is there, that is represented in terms of x multiplied by y bar plus z, x multiplied by x bar plus y plus z bar. So here it is written in terms of product of sum form. It is product of sum form. So all the first uh, terms, these terms individually are first adding, means here it is going to use OR gates. Okay, so ORing function is there. So first it is ORing and then it is ANDing. So that's why it is called product of sum form. So each standard form can be represented in terms of two forms, either sum of product or product of sum. So standard forms are of two type, sum of product and product of sum form. So this standard form can have two forms, like sum of product or product of sum form. Okay, so next we can see another form of standard form, standard representation. So here a function is there, that is suppose f3 is there. So this is f3 and it is given by like ab plus c de. So by seeing this we cannot say like what is its form, either it is sum of product or product of sum. So by observing it cannot, we can say like it is neither sum of product nor product of sum, neither sum of product nor product of sum. So any function can be written in terms of sum of product or product of sum, or it cannot be of the form. So if it is not of the form of sum of product or product of sum, then its circuit diagram if we want to draw, so from there we can see AB, first we need to do AB, then DE, inside the bracket this is DE, so R is there, so this is D plus E, then DE is AND with C, so it is C into D plus E, and then finally by adding these two we can get the function f3. Okay, so if we compare the product of sum or sum of product, we can see this is the product of sum, and sum of product is represented by two stage. Okay, two stage, or we can say two level. So this is level 1 and this is level 2. So this is level 1 and this is level 2. So this sum of product and product of sum is represented by a two level realization, or we can say two level implementation. So any standard form is there, so that standard form, either it is of sum of product or product of sum, we can represent that standard form into a two level realization. So the advantage of two level realization is, so suppose each gate is having a propagation delay, that is TPD. So this will also be having a TPD, propagation delay. So this is having suppose TPD and this is having TPD. So overall the delay of the circuit to represent f1 function will be one delay this one and another one delay this one. So total delay will be 2 TPD in terms of sum of product representation. Similarly, another function is there, that is in the form of product of sum, then the delay here also is 2 TPD. That means if two level implementation is there or two level representation is there, then it will be having 2 TPD delay. Okay, but in case of the next example, that is where f3 function is represented, so it is neither sum of product nor product of sum, then its realization with the help of circuit is like it is having three different levels. So level 1, level 2, level 3. So three different levels are there. So overall if we want to find out the delay, so here the delay will be 3 TPD. So if any standard form representation is there, we try to make it either in product of sum or in sum of product of, so that we should be having the minimum delay of the circuit possible. So now we need to convert this into two level representation form. So f3 can be represented like here. We can write ab plus, we can use the distributive function, distributive law. So here it will become c into d plus c into e. So now this is the form. So this is now the form of like, it is the form sum of product type. It is sum of product. So product terms have been sum. Okay. So now we can draw the circuit for this. So if we want to draw the circuit for this, it will be like having two levels, level 1 and level 2. So the same function can be represented in terms of level 1 and level 2. So here the delay is, instead of 3 TPD, we are having 2 TPD. So this is the advantage of writing a function in terms of either sum of product or product of sum, so that we will be using only 2-level realization or 2-level implementation of this function. That will be providing lesser delay. So this is your canonical form and a standard form. So in standard form, it can be represented in terms of product of sum and sum of product, and in canonical form, it will be represented in terms of minterms and maxterms. So I hope you have got the point. And also there is a function we have seen like here, the minterms and maxterms are complement to each other. And if we want to write minterms and maxterms of any function, we can directly write, or we can directly complement the function. So if a function is written in terms of like m0, m1, m2, m3, then that will be the minterms. It will be summation of minterms. But if we want to write in terms of product terms, so the product terms will be the remaining. So complement of this will be like whatever the remaining terms are there, so that will be in terms of product of sum terms. Okay. So this product of sum terms will not be like this, it will be product of sum terms where it will be constituting these terms. So that will be product of sum terms. It will be product of sum. So either a function can be represented in terms of this or in terms of this. So this is how alternatively it is used to represent a function. So this is we have seen. So based on that, we will see some questions. So here, express the Boolean function f is equals to this as sum of mean terms. We need to find out the sum of mean terms for this. So how we can proceed? Yes, anyone? If we want to write in terms of sum of mean terms. So here we can see like the function is having the variables, input variables are a, b, c, d. That means there are 4 variables. 4 variables are there. So if there are 4 variables are there, we have to write, so to directly write a function in terms of mean terms, we need to write the expressions first. So whenever a function is written, f is equals to this, and if it is having 4 variables, then if 4 variables are there, then possible combinations with respect to 4 variables are 4 to the power, or that is 2 to the power 4, that is 16 possible combinations of a, b, c and d will be there. Okay, so we will represent this in terms of all the possible combinations. So here a is written, so we can just see 0, 0, if this is a, b, c and d. So 0, 0, we will write all the possible combinations. So 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, if this is the combination. So we can just identify directly from here. So if we want to get the possible combinations, so suppose AD is there. So with respect to this, what is the different mean terms possible will be there? So we can just see A and D. A and D are 1 and 1. Okay. So whenever there is A and D that is 1, we will check for that. Okay. So here D is 1 but A is not 1. So whenever there is A and D both are 1. So here, okay. So this is the term where A and D both are 1. So there are 4 different mean terms that are having A and D 1. So we will write it. So this is M9, this is M11, this is M13, this is M15. So this AD will constitute these 4 mean terms. Similarly, we will see B bar and C. B bar and C means B is 0, C is 1. So we'll check for B and C where B and C, B bar is 0. So B bar is written means there B is 0. B bar is, if it is, if we talk about in terms of here, if we talk about the B and C, so B bar should be 1 or B should be 0. So with respect to that, B should be 0 and C should be 1. We can conclude from there. So we need to consider B is equals to 0 and C is equals to 1. So B is equals to C. Yeah, just we'll take another color. So B is 0, C is 1. So B is 0 and C is 1. So this is one term. So this is M2 is there. Okay. So B is 0, C is 1. This is also. So it is representing M3. So 0 and 1 we need to find out. So this is there and this is there. So this represents M10 and this is M11. So this B bar C represents 4 different terms. Okay. Next we need to find out A. So A should be 1. So if A should be 1 means wherever there is 1, A is equals to 1, we need to include all that mean terms. So here for that we can use another color. So this is for A is equals to 1. So this function for this is the mean terms representation. So for mean terms we know whenever there is a function that is 1 having one value with respect to that mean terms, that combination we need to consider. So that means each term should be 1. So each term should be 1. So to make this each term 1, A should be 1, B bar C should be 1 means at that time B should be 0 and C should be 1. So this term should be 1 and AD should be 1. So AD should be 1 means both A and D should be 1. So that combination we are searching for. So finally for A we need to consider like wherever A is 1, we need to take all that mean terms. So just consider this. So here A is 1, so up to here, so from this to this all is having A is equals to 1. So this will be M8, M9, M10, M11, M12, M13, M15. So 8, 9, 10, 11, 12, 13, 14. So it is M14 and then M15. So there are each term of this mean term is going to give different mean terms. So this one term is going to give different mean terms. This is going to give different mean terms. This is going to give different mean terms. So with respect to each term, we have found out different combination of mean terms. So we need to consider all of it. So we can just see. So if we want to find out, so we will be finding starting with M2 and M3 is there. So 2 and 3 is there. Then 8, 9 is there. 8, 9 and after that all are there. Okay. So 8, 9, 10, 11, 12, 13, 14, 15. So after that 8, 9, 10, 11, 12, 13, 14 and 15. So this is how we will be finding out the answers. So once a function, because it is not in standard, not in canonical form, we have to make it in canonical form. So either we can make it in terms of, if we want to make it in canonical form, if we want to make it in canonical form, then if each term should be in canonical form, means each term should be having all the variables. So here a is the only variable. So to write another variables, so we will be writing it like b is not there, c is not there, and d is not there. So we will be writing it like a into b plus b bar. So b plus b bar, we know it is 1. So if we are multiplying a with 1, there will be no effect on the expression. The expression will be same. Similarly, because all the input variables would be there in each term, so we will be again multiplying with c is also not there, so c plus c bar, and d is also not there, so d plus d bar. So this is with respect to that. So a should be represented in terms of canonical form by putting these extra terms. So by expanding it, we can represent in terms of canonical. Similarly, b bar c is there. So b bar c is there. So it is not having a term and not having d term. So to write a term, we will be multiplying by the a plus a bar into this, and to write d terms, d plus d bar, we will be multiplying. So it will become the, after expanding, it will be giving out different mean terms, and that will be constituting all the possible a b c d 4 variables. Similarly in ad, so ad is there, so we are not having b and c. So to have b, we will be writing b plus b bar multiplying by c plus c bar, and then after expanding each, we will be adding all. After adding all, the all mean terms combination will be generated. Now it is written in canonical form. So with this canonical form can directly give us the mean terms, or we can use this technique that we have just gone through to represent the mean terms. The next one is the express the Boolean function this as the product of max terms. So we need to write in terms of product of max terms. So here we can just see it is having x, y, and z. That means there are 3 variables. So there are 3 variables. That means instead of a 16 combination, we have to make 8 combinations. Okay. So x, y, and z. So with respect to that, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7. So these are the different possible combinations of x, y, and z. But now we need to write in terms of product of max terms. So we need to write in product of max terms. So either we can proceed directly to write the max term, or we can just go with like first find out the mean terms and then complement it. It will be giving out the max terms. It is written in sum of product terms. So we will be making it as it is. So it is x bar y plus x z. So to write each variables, we should be considering like x bar y, and z is not there, so we will be multiplying it by z plus z bar, plus here y is not there, so x, y plus y bar, we will be multiplying. Y plus y bar is 1, so there will be no effect, and then we will be expanding it, so it will become x bar y z plus x bar y z bar. This has become. Next is, this is x, y, and z, so it is x, y, and z, x, y, and z plus x, y bar z. So this is now in canonical form because each term is having all the 3 variables. So now if we want to write, so f can be represented by like summation. It is sum of product terms. So it is summation of product terms. So each product term we will be writing. So this is x bar yz. So x bar yz means x bar yz is 1. Yz is 1, x bar is there. So this is representing the M3. So this is M3, comma. This is x bar y z bar. X bar y z bar means this is 0, 1 and 0. This 0, 1 and 0 means it is M2 is representing. Next one is x y z. This is M7. X y bar z. So this is 1 0 1. That means it is M5. So that is the function that is written in M2, M3, M5, M7. So this is there. So this function in terms of product of sum or product of max terms will be represented by the complement. So complement, if we are doing the remaining terms we will be writing. So in product of some terms, it will be capital M0, capital M1, capital M4, capital M6 will be there. Okay. So with respect to three variable mean and max terms, from there, from 0, what is the max term? X plus y plus z. Okay. So similarly, for other terms we can just proceed. So for M0, x plus y plus z is there. Similarly for M1, capital M1, that is max term, so it will be wherever it is 1, so for 1 z should be 1, but that should be complemented form, x plus y plus z complemented. So 4 is there, so x will be complemented. 6 is there, so x and z will be complemented. So the mean terms will be 2, 3, 5 and 7. 2, 3, 5 and 7. 2, 3, 5 and 7. So max terms will be 0, 1, 4, 6. So 6 should be like, it should be x bar, y bar and z. Okay, so it should be x bar, y bar and z. So this is the term. Okay. The next question we will see. So here draw a two-level logic diagram to implement the Boolean function this. So the Boolean function is f is equals to b c bar plus ab plus acd. So we need to write a two-level logic diagram. So in two-level logic diagram means in the first one, here it is written in terms of sum of product. Sum of product means we need to first product it. So we will be ANDing. So we will take the a b, because c complement is required. So this is the way general way we write. We write if there is a complement requirement is there. So c complement is required. So b c complement is required. So we have complemented all the terms a b c d, 4 variables, and we will taking one at a time. So b and c bar. So b and c bar will be b and c bar, and AND with the help of AND. This is level 1 and this is level 2. In level 2 we will be making the OR, and in level 1 we will be making the AND. So this is all about the canonical and standard form and mixed mean term and max terms.